Hello folks, this is Andrew, and yeah, going to do something a bit different in, well, I guess not, but this was not a video that I had planned on making anytime soon, but I got a comment in another video requesting specifically this sort of thing, and you know, I live to serve, so this is going to be a video on the cranial nerves, specifically on the more sort of theoretical aspects of the cranial nerves. So we'll definitely be talking about the functions of the nerves, because that's fundamentally important to understanding everything else about them. We'll also have a talk about like the brainstem nuclei, and which cranial nerves come from which nuclei and where the nuclei are in the brainstem and all that sort of stuff. And then we can also talk a little bit about the modalities of the cranial nerves, you know, visceral afferent and somatic efferent and general and special and all that sort of stuff. And we can try and find a way of linking it all together, because it's a lot of confusing stuff. And I think when you sit down, I remember when I was teaching it last year, like sat down the week before thinking, right, I need to, you know, get on top of this before I teach it. I was just looking at it and thinking, fuck me, like, it's really, really complicated stuff. And it's very easy to sort of treat it all, right, oh my God, I need to learn all of the functions of the cranial nerves, and oh, I need to learn all of the brainstem nuclei, and sort of not see them as connected bits of information. Yeah, so that's what I'm going to try and do in this video. I'm going to try and show how it all can sort of feed into each other, and if you understand bits of the cranial nerves, then other bits suddenly make sense and all that sort of stuff. I'll say it now, what this video definitely isn't is I'm not going to be talking about the course of each cranial nerve or like the foramen of the skull that each cranial nerve goes through. I am actually planning on, I'm going to do maybe some shorts on each cranial nerve that answers those very sort of discrete, high-yield, fact-based bits on the cranial nerves. I'll do that over the next couple of weeks. But this video is much more sort of a deep dive into the sort of the theoretical stuff. Still very high yield for exams, sort of, you know, written exams or like theoretical questions in Vivas or OSCEs or whatever. So I'm hoping it's still going to be useful. And yeah, if you get this down, then there's nothing that could come up with the cranial nerves, nothing that could come up with neurology of the cranial nerves that won't make sense if you can get this straight in your head, he says. Okay, so yeah, let's give it a go and just see how we get on. So first things first, with the cranial nerves, I would say the one thing that you have no excuse for is not knowing the functions of the cranial nerves, and I mean all of the functions. Yeah, most of us get comfortable with like one or two functions of each cranial nerve as sort of, you know, the main ones that we come across. But actually, if you really want to get a deep understanding of how the nerves link to their modalities, how the modalities link to the brainstem nuclei, and how it all fits together, you do need to have a really clear understanding of every function of the cranial nerves. Yeah, so that's what I'm going to do first. We're just going to put together a table of every function of each of the cranial nerves. This might be a little bit time consuming, but I would argue, I would advise, make a table along with me. Yeah, don't just watch me do it, that'll be soul crushing, but make it along with me, because then you have that information sort of in one place. Okay, so this is the table that I would make. Got the 12 cranial nerves down the sides, and then we've got 4 columns going across. Now, these columns may seem arbitrary at first, but bear with me, because I'll explain why the 4 columns make sense a little bit later on. Yeah, what I've effectively done with these 4 columns is, for any function of any nerve, not just the cranial nerves, any nerve in the human body, the function of that nerve is either going to be somatic nervous system versus autonomic nervous system, because there are 2 functional classifications. Yeah, and then within each of those, it's either going to be an afferent nerve, i.e. conveying information from the body to the brain, or an efferent nerve, conveying information from the brain to the body. Yeah, so that's how I've sort of divided this up. Yeah, we've got the somatic nervous system here, autonomic nervous system here, and then each of those has a sensory and a motor component. Okay, so just a bit more detail. You think about the somatic nervous system, so somatic sensory, I mean, the name gives it away, doesn't it? This is going to be the information that goes to the somatosensory cortex of your parietal lobe, yeah? And this is effectively going to be our sensation of touch, isn't it? Yeah? Any cranial nerve that has a function that involves conveying the sense of touch is going to fall into this column. Somatic nervous system, sensory component, yeah? Somatic motor, so again, remember, somatic nervous system, in very, very simplistic terms, we say that this is the nervous system that we're consciously aware of, yeah? So your somatic motor, this is all going to be skeletal muscles that are under conscious control, yeah? So any cranial nerve that goes to a muscle that we can choose to contract is going to fall under our somatic motor column, okay? So far, so easy, yeah? The other two columns are the autonomic nervous system. So remember, this is the unconscious nervous system, what we don't really have much of a say over. It's probably a little bit lazy to call this sensory and motor. Really, it should be afferent, i.e. what affects the brain, and efferent, how the brain affects the body, yeah? But in very general terms, your autonomic sensory, this is going to be how the body communicates homeostasis to the brain. Yeah, whether that be chemoreceptors conveying pH changes, baroreceptors, changes in pressure, stretch receptors, changes in distension of an organ wall or whatever, yeah? All of those changes are getting sent, the information from that is getting sent to the brain via the autonomic sensory nerves, yeah? You might also see them written as visceral afferent fibers, visceral afferent neurons, yeah, conveying information. You've then got the efferent component of that, yeah, the autonomic motor component, which is basically what does the brain do in response to changes in homeostasis, yeah? We can come to the conclusion that your autonomic motor component is just going to be your sympathetic and your parasympathetic nervous systems, isn't it? Yeah, because in response to receiving information, your brain is either going to ramp everything up, yeah, which would be a disruption of homeostasis, isn't it? Yeah, if you've got physiological demands, i.e. running away from a bear, yeah, your brain will increase your heart rate, increase your blood pressure, increase your respiratory rate. It will go off homeostasis in order to meet the new physiological demand. Or once you've gotten away from the bear, it will re-establish homeostasis by slowing everything down, and that's your rest and digest sort of thing, isn't it? Yeah. But this is all sort of the autonomic efferent part of a nerve's function, isn't it? Yeah. And that's either going to be your sympathetic nervous system or your parasympathetic nervous system. Fight or flight, rest and digest. Okay. So there are four columns. And yes, I would argue that any function of any nerve in the human body, not just the cranial nerves, any nerve could fall into one of these four columns. Okay? So if we just go through them from the top, some of these nerves are going to be quicker than others because some of them are far more simplistic than others. Let's start off with cranial nerve 1. So cranial nerve 1 is the olfactory nerve. The olfactory nerve, nice and easy one to start off with. It's your sense of smell, isn't it? Yeah. Now I didn't actually say as I was going through these. You think about your sense of smell. Smell is one of your 5 special senses. Yeah, sight, hearing, smell, taste, and touch. Yeah. Just ask yourself the question: does information regarding smell go to your somatosensory cortex in the parietal lobe? No. Yeah. Touch is the only one that's going to fall into here. Anything else that is sensory, and that includes your other 4 special senses, is going to fall under this. It's going to be a visceral sensory and autonomic sensory. Yeah. So cranial nerve 1, nice and easy. We can just put smell in here. Yeah. Cranial nerve 2, the optic nerve, again, and nice and easy one. Obviously, you can really dive deep into the various aspects of sight. You know, you can talk about the afferent limbs of various reflexes, you can talk about visual fields and all of that sort of stuff. But ultimately, the optic nerve is responsible for conveying visual information to the occipital lobe at the back of the brain. Yeah. So again, it doesn't go to the somatosensory cortex, but it is a sense, it is sensory, so it's going to fall into here. Sight. Yeah. So far, so easy. Okay, cranial nerve 3. Cranial nerve 3 is the oculomotor nerve. Now, this is where we start to get a little bit more complicated. So the oculomotor nerve has a couple of different functions. The one, I think the function that most people are happy with, and most people come across most of the time, is the role that the oculomotor nerve plays in movement of the extraocular eye muscles. Yeah, so as the name suggests, oculomotor, it's a motor nerve that moves the eyes, and it's 4 out of your 6 extraocular eye muscles, isn't it? Yeah, got to get this right. It's your superior rectus, medial rectus, inferior rectus, and inferior oblique. Yeah, so let's just put the superior rectus, inferior rectus, medial rectus, inferior oblique. Yeah, and these are skeletal muscles that we consciously control. Yeah, if I want to look up, I can contract my superior rectus to pull my eyes up. Yeah, so this falls under somatic motor. Okay. The one other. There is one other muscle that falls into this column, and that's your, what's it called? The eyelid one. Levator palpebrae superioris. Levator palpebrae superioris, okay? Which is a muscle that elevates the eyelid. Again, innervated by the oculomotor nerve. Okay? Now, they're all skeletal muscles. They're all under conscious control, so they belong in this column. Yeah? But there is one other muscle. There's one other muscle that's innervated by the oculomotor nerve, and that's your sphincter pupillae muscle, or pupillae sphincter muscle. Okay, so this is going to be the muscle that constricts your pupils, makes your pupils smaller. Okay, now you can't consciously decide to do that. Yeah, you can't decide to make your pupils smaller. That's always in response to either something like your pupillary light reflex. Yeah, you shine a bright light in someone's eyes, the pupils constrict, because otherwise they're being overloaded with visual information. Yeah, it also falls under your rest and digest part of the nervous system, doesn't it? Yeah, because when you're running away from a bear, you want your pupils to be really, really big so you can get as much visual information in as possible. Once you get away from the bear, you're re-establishing homeostasis, your pupils shrink down. Okay, so it's a parasympathetic response. Yeah, so that's not going to be under conscious control. We're talking into this column here. Yeah, so sphincter pupillae. Yeah, and I'm just going to put in brackets parasympathetic nervous system. Yeah, because it's a parasympathetic response. Okay, so we can see that the oculomotor nerve ticks 2 of our columns. Yeah, both of them motor because it's called oculomotor, isn't it? Okay. Cranial Nerve 4, trochlear. Again, a really, really nice and easy one. The trochlear nerve is a motor nerve. It only innervates one muscle. The one muscle that the trochlear nerve innervates is the superior oblique, which is another one of your extraocular eye muscles. Yeah, it's responsible for pulling your eyes down and out. Yeah, and you can consciously constrict. You can consciously contract your superior oblique, so it falls into this one. Okay. I'm going to jump ahead to cranial nerve 6, just because that completes the set, doesn't it? Cranial nerve 6 is the abducens nerve. The abducens nerve is the last of our extraocular eye movement nerves. Again, there's only one muscle that it innervates, and that muscle is your lateral rectus. Yeah, remember abducens refers to abduction, and your lateral rectus pulls your eye out. Yeah, abducts it. And that's it. That's the only muscle that cranial nerve 6 applies. Again, it's a muscle under conscious control, so it falls into this column here. Okay. So that's our 3, 4, and 6. They're your extraocular eye muscle movements, nerves. Yeah. If we bump back up to 5, then if we go back up to the trigeminal nerve. So yes, cranial nerve 5, trigeminal nerve again has a couple of different functions, and I'm hoping we're aware of the couple of different functions. Yeah. The one that most people are happy with, that most people are aware of, is the trigeminal nerve is the nerve responsible for sensation of the face. Yeah, your trigeminal nerve's got 3 divisions, yeah, an ophthalmic, maxillary, and mandibular division, and each one of those is responsible for sensation of different parts of the face. Okay, now that is information that is going to go to the somatosensory cortex of the parietal lobe. Yeah, so sensation of the face is going to fall into this column here. Okay, so that's one function of the trigeminal nerve. Does the trigeminal nerve have any other functions? Yes, it does. Okay, so there are also muscles that are innervated by the trigeminal nerve. okay? And there's quite a few muscles actually that are innervated by the trigeminal nerve. The most, I suppose, well known and the ones that sort of come up most often are your muscles of mastication. Yeah, so remember all of your muscles that are involved in elevating your jaw, closing your mouth, yeah, temporalis, masseter, your lateral pterygoids, your medial pterygoids, they are all innervated by cranial nerve 5. These are muscles that you can consciously constrict, yeah, consciously contract, so they're going to fall into here, aren't they? Somatic motor, so muscles of mastication is one. Yeah, and then there are actually some other muscles that are also innervated by the trigeminal nerve. There's tensor veli palatini, which is one of the muscles of the soft palate. There's tensor tympani, which is a muscle that's in the ear. There's the mylohyoid muscle. Which is in the floor of the mouth. Any others? I think maybe the anterior belly of the digastric as well. Anterior belly, digastric. And I think that might be it. If there's any more, I'll pop it up somewhere on the screen. But, so there are a fair few muscles that are innervated by the trigeminal nerve, okay? Not just the muscles of mastication, there are others, okay? But all of these are skeletal muscles that are under conscious control, okay? So they do all fall into the somatic motor column, okay? And that is it for the trigeminal nerve. So again, is ticking 2 of our columns, yeah? And they're both the somatic columns. The cranial nerve 5 has no autonomic function. It has no role in homeostasis or sympathetic, parasympathetic stuff at all. It's all somatic. Okay? Whew, right, we're halfway. I'll be honest, that's the easy half done. Yeah, let's crack on. Okay, cranial nerve 7. So cranial nerve 7 is the facial nerve. And yeah, this is where stuff starts to, this is where you have to start paying attention to the details with regards to functions, okay? So again, if I try and predict what most people are comfortable with the facial nerve, I think most of us associate the facial nerve with control of the muscles of facial expression, yeah? All of the various muscles that raise your eyebrows, close your eyes, smile, frown, all of that sort of stuff. Because it's that whole to Zanzibar by motor car, isn't it? 5 branches of the facial nerve, yeah? Temporal, zygomatic, buccal, marginal mandibular and cervical, yeah? So muscles of facial expression, obviously under conscious control, so will fall under somatic motor, yeah? So muscles of facial expression. Okay, now again, technically, just be aware there are other muscles innervated by the facial nerve. Yeah, your stapedius muscle in the middle ear, stapedius, is innervated by the facial nerve. The posterior belly of digastric is innervated by the facial nerve. The stylohyoid muscle is innervated by the facial nerve. Yeah. Now I'm not going to go into detail about how to remember each of those muscles. Yeah. Much better to actually. Yeah, maybe I'll do a video on like the muscles of the neck and stuff like that, and we can break it up like that. But just the take-home message is, be aware that there are multiple muscles that are innervated by these cranial nerves. Yeah, but they are all skeletal muscle. They are all under conscious control-ish. So they all fall under this somatic motor component. Okay, so I think that's the most well known of the functions of the facial nerve. What else does the facial nerve do? You may have come across that the facial nerve is involved in taste. Yeah, your anterior 2/3 of the tongue. Yeah, general sensation from the tongue is conveyed, from the front of the tongue is conveyed by the trigeminal nerve, but taste fibres from the anterior 2/3 of the tongue is conveyed by the facial nerve. Now, taste is one of our special senses, yeah? It's not going to go to the somatosensory cortex in the parietal lobe, it's going to go to specific taste receptors elsewhere in the brain, yeah? So we're going to go over here to our autonomic sensory, and we're putting in here taste, anterior 2/3 of tongue. Okay, so it's ticking that one as well. Yeah. Anything else that the facial nerve does? Yeah, facial nerve is also involved. So your facial nerve is the one that makes you cry, snot and slobber. Yeah, that's a nice way of remembering it. Yeah, your facial nerve is responsible for crying, snotting and slobbering everywhere. Yeah, so lacrimal gland. Yeah, the production of tears to make you cry. Facial nerve. Nasal and oral mucosa to produce buckets of mucus. Yeah, to make you snotty. Yeah, facial nerve. And then 2 out of our 3 main salivary glands, yeah, our submandibular and our sublingual salivary glands, again innervated by the facial nerve to help produce saliva. Okay, so these are all out of our conscious control. Yeah, they are autonomic functions. And again, if you think about, I mean, just think when you're running away from a bear, do you want to be crying, snotting and slobbering everywhere? No. So it's unlikely that these are going to be part of the sympathetic nervous system. They're going to be part of the parasympathetic nervous system. Okay? And certainly saliva, that makes sense, doesn't it? Rest and digest, or saliva is needed to digest. Okay? So over here in the autonomic motor, we've got lacrimal gland to make you cry. We've got oral nasal mucosa to make you snotty. And then we've got the submandibular and sublingual salivary glands to make you slobber, yeah? And again, I'm going to put in brackets, parasympathetic nervous system, yeah? So far, all of these cranial nerves have been doing parasympathetic functions, not sympathetic functions, okay? So then that's the autonomic motor function of cranial nerve 7. We've only got one column left. Does cranial nerve 7 send anything to the somatosensory cortex of the parietal lobe? Technically it does, yeah. There is actually a part of the external ear that does send sensation fibres, general sensation fibres, to the parietal lobe. So it's, external auditory meatus. Yeah, and that is often missed. Yeah, you'd be forgiven for not realising that the facial nerve has any role to play in general sensation. Yeah, but there is a small part of the ear that it does innervate. Okay, so we can see the facial nerve is ticking all 4 of our columns. Okay, it has functions across the entire sort of functional spectrum of the nervous system. Okay, so just bear that in mind. Okay. Oof, right, moving on. Cranial nerve 8. Oh, nice and easy, isn't it? Yeah, cranial nerve 8, your vestibulocochlear nerve. Vestibular refers to balance, cochlear refers to hearing. Yeah, it's your sense of balance, sense of hearing. These are sensory, but they're not going to go to the somatosensory cortex. Yeah, they're special senses, so they're just going to fall into this autonomic sensory column. Yeah, hearing and balance. Nice and easy, okay? Moving on, cranial nerve 9, glossopharyngeal nerve, another really, really picky one, yeah? So let's just put some functions on there. So your glossopharyngeal nerve, so the glosso part of glossopharyngeal refers to the tongue, and we're talking about the posterior third of the tongue. General sensation of the posterior third of the tongue is glossopharyngeal. So posterior third of tongue is going to go to the somatosensory cortex via the glossopharyngeal nerve. But then the glossopharyngeal nerve also carries taste from the posterior third of the tongue. Yeah, so we've also got taste, posterior third of tongue, going via the glossopharyngeal nerve. Okay, so already 2 out of our 4 columns ticked off. Yeah. Other functions of the glossopharyngeal nerve. There is one skeletal muscle that is innervated by the glossopharyngeal nerve, and only one in the whole body. Anyone that's come across it, it's stylopharyngeus. Yeah, stylo-9-0 is the way that I have to remember it. Yeah, cranial nerve 9-9-0. Stylopharyngeus is the only skeletal muscle in the human body that is innervated by the glossopharyngeal nerve, but technically it does fall into this column. Yeah, it's a skeletal muscle under somatic nervous system control. Okay, And then finally, do we have any autonomic motor functions of the glossopharyngeal nerve? Yes, we do, because the other salivary gland, the biggest salivary gland, the parotid gland, is innervated by the glossopharyngeal nerve. And again, producing saliva, rest and digest, it's going to be parasympathetic nervous system. Okay, so again we can see the glossopharyngeal nerve ticking all 4 columns. Now, is there anything else? Yes, there is. Yeah, there is some sensation, elements of sensation of the soft palate and oropharynx. Get their sensory innervation from cranial nerve 9. Yeah, you think about your gag reflex. Yeah, the afferent nerve in that reflex is the glossopharyngeal nerve. Yeah, you stimulate the back of the throat, it gets transmitted to the glossopharyngeal nerve to then stimulate the efferent response, which is to make you gag. Anything else from, yeah, we've got other stuff as well, we're still going. Let's go back over to this column here, the autonomic sensory column. So we've already talked about taste. Yeah, taste from the posterior third of the tongue is involved by the glossopharyngeal nerve. The glossopharyngeal nerve also has wider functions to play in homeostasis, and we're starting to think about things like baroreceptors and stuff like that. Your glossopharyngeal nerve conveys information from your carotid bodies, and your carotid bodies are baroreceptors found in your common carotid artery, or just at the bifurcation of the common carotid arteries into the internal and external, to convey changes in blood pressure to let the brain know if you're becoming hypovolemic or something like that. So again, that is going to be conveyed by the glossopharyngeal nerve. Okay, so there's a lot going on with these nerves. Yeah, there's a lot of functions here, and I wouldn't be surprised if I've even missed one. I think that's everything. I'm hoping that's everything. But yes, this is the glossopharyngeal nerve, again ticking all 4 of our columns. Yeah, with lots of different functions to be aware of. Okay, the vagus nerve, again a very, very busy one. Yeah, it does a lot in the human body, the vagus nerve. So let's go through these fairly quickly. You're just going to have to take my word on a lot of these functions. So somatic sensory, does the vagus nerve have any sort of general sensation to convey to the somatosensory cortex of the parietal lobe? Yes, it does. It conveys some information from the pharynx, in particular the laryngopharynx. Sensation from the larynx itself goes via the vagus. Some sensation from the esophagus goes from the vagus. Again, the ear, elements of the ear go via the vagus. I'm pretty sure like the epiglottis. I think the epiglottis conveys sensory information via the vagus nerve as well. So again, lots of structures around the throat is the take-home message here, are conveyed by a combination of the glossopharyngeal and the vagus. Yeah, so that is the that's the somatic sensory component of the vagus. Any muscles innervated by the vagus nerve? Yes, quite a lot of muscles innervated by the vagus nerve. I would say that when you're learning about the palate, when you're learning about the pharynx, when you're learning about the larynx, when in doubt, say vagus for these muscles. Yeah, the majority of the muscles of the soft palate are vagus. The majority of the pharyngeal muscles are vagus, and all of the laryngeal, the intrinsic laryngeal muscles are vagus. Yeah, so lots and lots of skeletal muscles around the neck innervated by the vagus nerve, falling under somatic motor. Yeah, autonomic sensory. So does the vagus nerve have any role to play in communicating homeostasis or changes in homeostasis to the brain? Yes, huge amounts. Yeah, so we've got We've got things like the aortic bodies / sinus, yeah, which again are chemoreceptors and baroreceptors in the aorta that can convey changes in blood pressure, changes in pH via the vagus nerve to the brain. You've then got just visceral information from most of the thorax, thoracic and abdominal organs. Yeah, your lungs, your heart, your GI tract, your liver, most of the organs, almost all of the organs in your thorax and abdomen, if they have any change to their internal environments, they are going to communicate that via the vagus nerve. Yeah, the vagus nerve does everything in the thorax and the abdomen from an autonomic point of view. Okay, so yes, specific examples are like the aortic bodies and stuff like that. But when in doubt, if the question is, how does a thoracic or abdominal organ communicate visceral afferent changes, it'll be the vagus nerve. Yeah, and then from the autonomic motor point of view, the take-home message is, again, with your thorax and your abdomen, the parasympathetic innervation of everything is the vagus nerve. Yeah, heart, lungs, esophagus, stomach, biliary system, intestines. Yeah, literally every thoracic or abdominal organ, by and large, you can think of, yeah, up as far as the embryological hindgut, which I'm not going to talk about, but the parasympathetic nervous system, innervation to all of that is the vagus nerve. Yeah, so that makes it that almost makes it nice and easy to remember. Yeah, so again, vagus nerve ticking all 4 columns. Okay, that's the end of the hard work, thankfully, because these last 2 are piss easy. Yeah, cranial nerve 11. Cranial nerve 11 is the accessory nerve. The accessory nerve is responsible for shrugging your shoulders and turning your head. Yeah, so sternocleidomastoid to turn your head, trapezius to shrug your shoulders. Okay, skeletal muscles under conscious control. It's going to be these 2. So sternocleidomastoid and trapezius. And then finally, cranial nerve 12, the hypoglossal nerve, again a purely motor nerve. Hypoglossal refers to underneath the tongue. This is going to be the the nerve that supplies most of the muscles of the tongue. So it's your intrinsic and extrinsic tongue muscles. Yeah, again, under conscious control, skeletal muscles, so fall under the somatic motor column. Okay, so that's it. Yeah, these are the functions of the cranial nerve, and like I said right at the beginning of this segment, like, you do need to know all of this. Like, you're not able to use the cranial nerves clinically to get an understanding of what a patient is presenting with if you don't understand what each cranial nerve actually does. Yeah, so I'm hoping you've made a table along with me as I've made this, because otherwise you're going to have to screenshot and rely on my handwriting, which is dire and has gotten worse as we've gone through. But yeah, so these are the functions of the cranial nerve. Now that we've got these functions down, we can then link it to everything else that we're going to talk about in this video. Okay? Okay. Before we move on to the brainstem nuclei, before we sort of try and relink all of this to where this is all happening in the brainstem, I do want to have a quick chat about modalities, because this is, I didn't understand it at all when I first sat down to try and learn about it. So yeah, all neurons in the human body have a modality, and the modality is basically referring to what information is being carried by that particular neuron. Yeah, and different neurons are designed in a way to carry different types of information. With regards to the cranial nerves, there are 7 different modalities in total, and that can be very, very overwhelming when you initially sit down and try and learn about them. So what I want to try and do is I want to try and break the modalities down into something that's a simpler way of thinking about it, and then applying that to this table, and hopefully trying to get you to understand that if you just apply a couple of rules, you can actually figure out what nerves carry which modalities and all that sort of stuff. Okay, so we'll start off with a couple of easy ones. I want to start off with this left-hand column. Yeah, this left-hand column is all of our somatic sensory functions. So it's all conveying information to the somatosensory cortex of the parietal lobe. Yeah. Now, the modality of the neurons carrying all of this information, regardless of which cranial nerve we're talking about, it's all the same modality. Yeah. Now, this is all afferent information. Yeah, it's all going from the body to the brain, so it's afferent. It is all somatic information, so it's a somatic afferent. Yeah, and because we are talking about general sensation, yeah, all of these are conveyed via general somatic afferent neurons. Yeah, which means if the question came up, which are the cranial nerves that have general somatic afferent fibers, general somatic afferent neurons, the answer is cranial nerve 5, cranial nerve 7, cranial nerve 9, and cranial nerve 10. Because these are the cranial nerves that convey general sensation to the somatosensory cortex. Okay, so all of these are general somatic afferent, GSA modality. Okay, so that far left column, nice and easy. This far right hand column, also nice and easy. So just a sort of reminder, so these are the cranial nerves that have either a parasympathetic or a sympathetic function. If you actually just have a look here, it's all parasympathetic. Yeah, that's actually a really good learning point to take away. There are no cranial nerves that have sympathetic nervous system functions. There's no fight or flight stuff going on in any of your cranial nerves, yeah? It's all rest and digest coming from cranial nerve 3, cranial nerve 7, cranial nerve 9, and cranial nerve 10. Okay, so just don't get caught out by that, because, you know, if let's say a question, again, thinking sort of exam-wise or whatever, if a question came up, what nerve is responsible for dilating the pupils? Dilating the pupils is sympathetic, it's fight or flight, but because it's in the eyes and because it's all up here, you'd be tempted to think that it must be something to do with the cranial nerves. It's actually not. Yeah, dilation of the pupils actually comes from much lower down off your spinal cord, around the level of T1. Yeah, so just keep that in mind. Only parasympathetic from the cranial nerves. Yeah, cranial nerve 3, 7, 9, and 10. Okay, but these are all efferent fibers. Yeah, they're going from the brain to the body, so they're all efferent. Yeah, they're all visceral. Yeah, we're not acting on skeletal muscles here. We're acting on either smooth muscle or organs. Yeah, so that's visceral. And again, because it's sympathetic and parasympathetic, it's just the general autonomic nervous system. That's a bit of a stretch, that last bit, but all of these are all carried via general visceral efferent fibers. Yeah, efferent because they're going from the brain to the body, visceral because they're involving visceral structures, and general because we're talking about the general autonomic nervous system. Okay, so again, if the question ever came up, which cranial nerves carry GVE fibers, your answers are 3, 7, 9, and 10. Okay? Now, they're the two easy ones, yeah? If you're paying attention, you're thinking, well, we've now, I said there are 7 modalities in total. We've done 2. We've now got to fit 5 into these remaining 2 columns, yeah? So this is where we've got to start coming up with rules and like little helpful things to help us sort of remember, yeah? Let's do this column first. Let's do the somatic motor column. So, all of these are skeletal muscles. They're all muscles that are under conscious control. Yeah, that's why they're in this. That's why they're in this column. Within this column, we've got 2 different modalities working. Yeah, 2 different types of modality working. And the reason there's 2 different modalities is because of all of these skeletal muscles, there are two different embryological origins. Some of them have derived from one aspect of the embryo, some of them have derived from another aspect of the embryo, okay? The question you need to ask yourself with this column here is the muscle I'm thinking about, is the nerve that I'm thinking about derived from something called the pharyngeal arches? Yeah? Now, I'll be honest, I don't know nearly enough about the pharyngeal arches to stand here and talk about them, but if you give them a Google, your pharyngeal arches are, from the looks of things, quite ancient embryological sort of, fish have them, that's how old we're talking evolutionary terms. They are basically just early structures that develop within the embryo, usually by around week 3, week 4 of development, that then go on to form a lot of the structures of the head and neck. Okay, so they're your pharyngeal arches, and you have 6 pharyngeal arches in the embryo. We're only interested in 4 of them. I'm not going to go into any more detail than that because I don't think I'm not aware of any usefulness beyond that point. But the question we're asking in here is, which of these are derived from pharyngeal arches? And we can break it up. The ones that are derived from pharyngeal arches are any muscle innervated by 5, any muscle innervated by 7, any muscle innervated by 9, and any muscle innervated by 10. Okay? 5, 7, 9, and 10. These are the muscles that are derived from your pharyngeal arches. Anything innervated by the trigeminal is derived from your first pharyngeal arch. Yeah, so masseter, temporalis, tensor veli palatini, mylohyoid, all derived from the first pharyngeal arch. Anything innervated by the facial nerve, derived from the second pharyngeal arch. Stylopharyngeus, the one muscle innervated by the glossopharyngeal nerve, is derived from the third pharyngeal arch, and any muscle innervated by the vagus nerve is derived from the fourth pharyngeal arch. So these are the ones that are derived from the pharyngeal arches. All of these other skeletal muscles that fall into this column are not derived from the pharyngeal arches. They are just derived from the normal sort of evolutionary, embryological sort of processes. Okay? Now, the ones in red, the ones that are not pharyngeal arch derived, their modality is what you would logically expect the modality to be. Yeah? These are efferent fibres that are in the somatic nervous system, and because they're not special, yeah, they're not derived from a funky arch or whatever, they are just general, yeah, they are your general somatic efferent fibres, yeah. So cranial nerve 3, cranial nerve 4, cranial nerve 6, and cranial nerves 11 and 12 carry general somatic efferent fibres. Incidentally, moving away from the cranial nerves, any nerve in the human body that supplies a skeletal muscle will be carrying these. Yeah, that this is the modality of muscles that supply, of nerves that supply muscles anywhere. Yeah, so general somatic efferent for these ones in red. For these ones in blue, the pharyngeal arch derived muscles. Yeah, just basically think about how wrong you could make this, and then that's the correct answer. Yeah, it is still efferent. Yeah, they got that bit right. Yeah, it is still going from the brain to the body. But then for whatever reason, they've decided that it's visceral efferent and that it's special. I don't know why. I don't know why. I wish I knew why. Yeah, it doesn't make sense at all. We're in the somatic nervous system and it's skeletal muscle. I don't know. But if it's derived from the pharyngeal arches, which is 5, 7, 9, and 10, the modality of the fibres communicated by these neurons is special visceral efferent. Okay, but then these are the two that account for this whole column. Yeah? Okay. Last but not least, so that's 1, 2, 3, 4 modalities down. We've got 3 left, and we've got 3 modalities to pack into this last column. So last column here, so this is our autonomic sensory column, yeah, which, I mean, if you just think about what that entails, this is going to, that includes a wide variety of different functions. Yeah, we've got, you know, we've got elements of special senses going on, but then we've got other things like balance, which don't really fall under a special sense, but it's still sensory information. We've got baroreceptors, chemoreceptors, we've got all sorts of, you know, lots of different things. So it makes sense that there's going to be a fair few modalities at work because there's lots of different information being transmitted in this column. Yeah? So we've got to be careful here. Now, all of these three, they're all going to be afferent, aren't they? Yeah, because it's going to the brain. Yeah, so it's all afferent fibres. Let me just, what's going to be the best way to break this up? Okay, I would say the one I'm going to do first is, if it's not involved in a special sense, yeah, if it's not involved in one of your special senses, it is basically going to be the afferent equivalent of this. Okay, so if we look down this column, smell, special sense, ignore it. Sight, special sense, ignore it. Taste, special sense, ignore it. Hearing and balance, special senses, ignore it. You go down to as far as the Glossopharyngeal Nerve, we've again got taste, special sense, ignore it. But the carotid bodies stuff, all of that baroreceptor, chemoreceptor stuff, that's not to do with the special senses. Yeah, and then cranial nerve 10, again, all of the stuff coming from all the information coming from your thoracic and abdominal organs, not special senses. Okay, so these are basically going to be the equivalent, the afferent equivalent of this, yeah? They are afferent fibres carrying general visceral information. Okay, so yeah, so the you would argue that cranial nerve 10, cranial nerve 9 carry general visceral afferent information, conveying information about blood pressure and pH changes and all of that sort of stuff via these nerves. Okay? With what's remaining, all of our special sense stuff, the only way that I can sort of figure out how to divide these up is to ask the question, are we talking about digestion or not? Are we talking about eating or not? Are we talking about the whole sort of principle of food or not? Okay, and I'll explain what I mean. If you look at the special senses and ask yourself which ones of these are involved in food, you would argue that smell is involved in food and taste is involved in food. Yeah, in which case that divides. So we've got this one in red, we've got this one in red, we've got this one in red, and then that just leaves sight and hearing and balance left in green. Yeah, now that is how we divide up the remaining two modalities, yeah, and that's the way that I think about it. Is it involved in food or not? I don't know whether it is actually something to do with whether it's endoderm derived embryologically or something else. I'm not entirely sure, but this is how the remaining two are divided up. Okay, the ones in red, so the ones that are involved with food, yeah, it is afferent information. It is visceral afferent information, yeah, because we're talking about the digestive system and all of that sort of stuff, but they're special senses, so they are special visceral afferent fibres, yeah, conveying the sense of smell and your sense of taste. Okay, so the olfactory nerve carries SVA fibres, yeah, the facial nerve carries SVA fibres to communicate via the chorda tympani branch, yeah, to communicate taste via the anterior 2/3 of the tongue. Okay, and same with the glossopharyngeal nerve here. Okay, the ones in green, again, I struggle to understand why this is named the way that it is, but again, it is afferent information. Yeah, they're not calling it visceral, they're calling it somatic, which would beg the question of why doesn't this belong over here? I'm not entirely convinced it is somatic, but I don't know. And again, because these are special senses, they are special somatic afferent. Yeah, so that's going to be the optic nerve, cranial nerve 2, and the Vestibulocochlear Nerve, Cranial Nerve 8. Okay, so that might actually seem like a lot of work, and it is a lot of work, yeah. But this is how a really deep understanding of the functions of each cranial nerve can then link to the modalities of it. Because you can see here, like if we use cranial nerve 9 as an example, if we use the glossopharyngeal nerve as an example, the glossopharyngeal nerve is that one nerve carries 1, 2, 3, 4, 5 different nerve modalities. Yeah, it carries GSA for general sensation. It carries SVE for skeletal muscle innervation. It carries SVA and GVA fibres for the autonomic nervous system, and then carries GVE fibres to the parotid gland. Yeah, and if you didn't understand that these were all of the functions of the glossopharyngeal nerve, then maybe you wouldn't understand why this one nerve is carrying so many modalities of fibres. Yeah, so that's why this is how it all sort of matches together. Yeah, you can tell I'm knackered. This is hard work. Like, this is really, really complicated stuff. And you know, you might end up coming to the conclusion that actually it's just easier to try and rote learn this for the sake of an exam and then just immediately forget it afterwards. But if you were wanting to try and understand this a bit more deeply, this is how I think about it, and this is how I've sort of broken it down. Okay, so 7 modalities of fibres in total, divided across our 4 columns. And in the next bit, I'm going to talk about why I chose 4 columns in the first place. Ooh, okay, this is turning into a ridiculously long video, so I'm going to try and keep this last bit a little bit more concise. Last but not least, we need to talk about the brainstem nuclei. Yeah, we need to talk about how all of these and all of these different modalities and all this sort of stuff actually relate to the cell bodies of these neurons in the brainstem. Yeah, and to talk about this, I want to go back to this initial table that I created with these 4 columns, yeah? Because you could make the argument, well, if I was going to end up talking about these 7 modalities, why didn't I just make 7 columns, 1 for each modality, and we sort of go through it that way? Which I would actually argue as a revision technique would be an absolutely fantastic thing to do, yeah? If you've copied this as I've done it, your way to check your consolidation would be to redraw the table, but with each of the modalities at the top and seeing how much you can match it up and all this sort of stuff. That'd be fantastic. The reason I decided to break our functions up into these 4 groups is my principle here is the number of columns that each cranial nerve fills is the number of nuclei that cranial nerve has in the brainstem. Yeah? So cranial nerves 1 and 2 we have to ignore, don't we? Because they don't go to the brainstem at all. Yeah, cranial nerve 1 very much stays at the front of the head. Cranial nerve 2 goes via the thalamus in order to get back to the occipital lobe. Doesn't go through the brainstem. Yeah? So we can ignore cranial nerves 1 and 2. Yeah? Cranial nerve 3, the oculomotor nerve, we can see that it filled 2 of our columns. It ticked 2 columns out of 4. Therefore, it has to have 2 nuclei in the brainstem. Yeah? Cranial nerve 4 only has 1. Cranial nerve 5, again, has to have 2 nuclei in the brainstem because it ticks 2 of our columns. Yeah? And if you look at cranial nerve 7, 9 and 10, each one of these nerves has to communicate with 4 nuclei in the brainstem, 4 separate nuclei in the brainstem. Yeah, and again, this is just a question of trying to aid your understanding as to how these nuclei are arranged. Yeah, but that is why I did it in 4 columns. Yeah, because you can then link the functions to the number of nuclei it has in the brainstem. No cranial nerve has more than 4 nuclei in the brainstem. It's a maximum of 4 for 7, 9 and 10. All of these others, if it ticks 2 columns, it's 2 nuclei. If it ticks 1 column, it's 1 nuclei. Yeah, so with a bit of understanding like that, let's now have a look at these nuclei and see if we can try and match them up. Yeah. Okay, let's put the brainstem nuclei up onto a diagram. Now, I'm not going to try and reinvent the wheel with this. Yeah, if you've ever studied brainstem nuclei, you'll have come across that picture where all of the afferent nuclei are on the left-hand side and all the efferent ones are on the right-hand side. Yeah. So we are basically going to recreate that diagram just with the links that hopefully we've been trying to make throughout the rest of this video. Okay. So if we do the afferent nuclei first, so this is going to be, you think this is going to be column 1 and column 3, isn't it, of that table that we drew? All of the afferent stuff coming in this side, yeah? Now, if we look at that for the very first column, that somatic sensory column, yeah, we had 4 nerves in total in that had functions with that. Cranial nerve 5, cranial nerve 7, cranial nerve 9, cranial nerve 10, yeah? The really nice and easy thing with this is that all 4 of those nerves carrying those general somatic afferent fibers, they all just go to the same nucleus. Yeah. Now it's a pretty big nucleus. Yeah, it's an absolutely huge nucleus, but it is all just the one nucleus. Yeah, and that is your, let's put it up here, your trigeminal sensory nucleus. Yeah, to be clear, receiving GSA fibers from cranial nerve 5, cranial nerve 7, cranial nerve 9, and cranial nerve 10. Yeah, all 4 of those nerves come into the trigeminal sensory nucleus. Now, I'm not going to go through this nucleus in a lot of detail, but if you have studied it, remember there are 3 parts. There's the mesencephalic part, the principal part, and the spinal part, and different types of sensation go to different parts of the nucleus. Yeah, proprioception goes up here, discriminative touch goes down here, pain and temperature sensation go down here. But it's the sensation being carried by all of these cranial nerves. Yeah, cranial nerve 5 from the majority of the face, cranial nerve 7 from the ear, cranial nerve 9 from elements of the soft palate and the pharynx, and cranial nerve 10 from, again, the pharynx, the larynx, that sort of thing, yeah? Proprioception from all of those is going to go here, discriminative touch from all of those is going to go here, and pain and temperature from all of those is going to go here, yeah? So one nucleus to account for that whole column of that table, yeah? They all go to the trigeminal sensory nucleus. So far so easy, yeah? So if you think that removes all of column 1, that takes care of all of column 1, we've then got column 3, yeah, that autonomic sensory column to account for here. Now remember, from that column, cranial nerve 1, cranial nerve 2 are out, yeah, they don't go to the brainstem at all, so ignore those 2. So then that leaves us with cranial nerves 7, 8, 9 and 10, doesn't it? Yeah, facial, vestibulocochlear, glossopharyngeal, and vagus. Okay, now you look at those 4 nerves, the way we divided the modalities up, there were 3 modalities across all of those, but 2 of those modalities were visceral afferent. We just had to differentiate between general visceral and special visceral, yeah, and then we had the one somatic afferent, the special somatic afferent, which was the vestibulocochlear nerve, yeah? And that's how we're going to divide up the nuclei, yeah? That one nerve that carried special somatic afferent fibers, yeah? The vestibulocochlear nerve gets its own nucleus, yeah? And that nucleus is sort of round about here-ish. Yeah, that is the vestibulocochlear nucleus. Yeah, receiving special somatic afferent fibers from cranial nerve 8. Okay? Which then leaves all of the others, so that was a combination of general visceral afferent fibers and special visceral afferent fibers from cranial nerve 7, 9 and 10, yeah? All of those visceral afferents, again, come to one single nucleus, one solitary nucleus, you might want to call it, yeah? That nucleus is going to be roughly around here, and this nucleus is called nucleus solitarius, yeah, receiving general somatic, no, receiving general visceral afferent and special visceral afferent fibres from cranial nerves 7, 9 and 10. Okay, and between those three nuclei we have then completely covered all of column 1 and column 3. Yeah. Now, with regards to where these nuclei are, yeah, I mean, you can see there. I'm hoping I'm roughly in the right place. Yeah. I've not paid too much attention to where the nuclei are. Your take-home message here is, if you know where the cranial nerves themselves come off the brainstem, the nuclei aren't going to be far away. Yeah. And if we rely on this. I didn't even say at the beginning, this is the brainstem, midbrain, pons and medulla. I hope that came across. Yeah, let me just, I'll fill that in. Midbrain, pons and medulla. Just remember, as a general rule, bearing in mind that cranial nerves 1 and 2 are out, they don't go to the brainstem at all. The first 4 go to the midbrain, which basically just means 3 and 4 come off the midbrain. 5 to 8 come off the pons, and 9 to 12 come off the medulla. Yeah, you can divide them up into sets of 4. Okay, and we can sort of see that here. Yeah, if this is, we know that the trigeminal sensory nucleus is a huge nucleus, but trigeminal makes us think of cranial nerve 5. Cranial nerve 5 comes off the pons, so most of the nucleus is found in the pons. Yeah, the vestibulocochlear nucleus, cranial nerve 8. Well, cranial nerve 8, again, it's sort of, you think about where it comes off the brainstem, it's sort of that pontomedullary junction. So we see the nucleus at the pontomedullary junction. Yeah, and fine, you know, elements of 7 are technically in the pons, but 9 and 10 are the main nerves that come to the nucleus solitarius. So it makes sense, 9 and 10 both come off the medulla, so nucleus solitarius is in the medulla. Yeah, so that's just generally the way to think about it. If you know roughly where the cranial nerves come off the brainstem, then where the nucleus is makes sense. Okay? Okay. So, that's the afferent side done. Yeah, only 3 nuclei to be aware of on the afferent side. Okay, if we now go to the efferent side, a lot more nuclei, but I'm hoping the rules are actually much simpler. Yeah, so efferent is going to be columns 2 and columns 4 of the table. Yeah, so column 2 was all of our somatic motor stuff. Yeah, the skeletal muscles that are innervated by the somatic nervous system. Yeah, and we have that combination of general somatic efferent fibres and then those really weird special visceral efferent fibres if it was derived from a pharyngeal arch. Yeah, but the take-home rule here, with a couple of exceptions, but for those somatic motor ones, every nerve gets its own nucleus. Yeah, so we think about the nerves that filled in that second column. Yeah, so our first one was cranial nerve 3. Yeah, the oculomotor nerve with its extraocular eye muscles. So there will be an oculomotor nucleus. It gets its own nucleus. Cranial nerve 3 comes off the midbrain, so we'll put that nucleus roughly about there. Yeah, cranial nerve 4, trochlear nerve. Yeah, it has to get its own nucleus, so we'll put the trochlear nucleus somewhere like that. Yeah, cranial nerve 5, remember the muscles of mastication and all of those other ones that fell into that somatic motor column. So there has to be a trigeminal motor nucleus, which we'll put round about there-ish. Abducens nerve, cranial nerve 6, exactly the same. There has to be an abducens nucleus somewhere. Yeah, the facial nerve had skeletal muscles. They supplied the muscles of facial expression and all this sort of stuff. So there has to be a facial motor nucleus. Yeah, cranial nerve 8, purely sensory, so we don't need to worry about that. And then we get a little bit more complicated. I'll talk about 9, 10 and 11 in a second. We go all the way to the end, cranial nerve 12. The hypoglossal nerve, purely a motor nerve, so there has to be a hypoglossal nucleus at the bottom there. Yeah, so for the vast majority of these motor nerves, they get their own nucleus. Yeah, the exception, because there's always exceptions, are 9, 10 and 11. Glossopharyngeal, vagus and accessory nerve. These 3, they don't get their own nucleus. They're a little bit more ambiguous, you could say. Yeah, so they basically get one nucleus together, which is called your nucleus ambiguus. Yeah, and nucleus ambiguus is going to be giving off the fibres that carry the information to the skeletal muscles, carried by 9, 10, and 11. Yeah, but with all of these other ones, cranial nerve 3, cranial nerve 4, cranial nerve 5, cranial nerve 6, cranial nerve 7, and cranial nerve 12, if they are in that somatic motor column, they just get their own nucleus. Okay, so that's enough. And you can, again, you see, I've just thrown them up there based on this basic knowledge. The midbrain is going to be 3 and 4, the pons is going to be 5, 6, 7, 8, and the medulla is going to be 9, 10, 11, 12. Yeah, but that's the general idea here. So that's then taken care of that second column of the table. Last but not least, we've got that final column of the table, which was our parasympathetic column, wasn't it? Yeah. So for example, if we look at cranial nerve 3, for example, we've ticked one of the boxes. Yeah, we've ticked its somatic motor box, but it now also needs a nucleus for its parasympathetic function. Yeah. And again, for this efferent side, each nerve that has parasympathetic function will get its own nucleus for that parasympathetic function, in much the same way that they all got their own nucleus for their somatic motor function. Okay, so cranial nerve 3, so the parasympathetic function was constriction of the pupils, yeah, the sphincter pupillae muscle. There's no way to easy way to remember this. The name of the nucleus responsible for that, and it's right next door to it, is Abducens Westphal nucleus. Yeah, named after the 2 guys that discovered it. Yeah, Abducens Westphal nucleus. But again, this is for the parasympathetic function of cranial nerve 3. Yeah, parasympathetic nervous system. Okay. You think about our other parasympathetic nerves of the cranial nerve. So we had 7 and 9. Didn't we? Cranial nerve 7, cranial nerve 9. I've put them together because they were both involved with the salivary glands, weren't they? Yeah, cranial nerve 7 makes you cry, snot and slobber, so it supplied the sublingual, submandibular salivary glands, and then cranial nerve 9, the glossopharyngeal nerve, supplied the parotid. Okay, so because these both are involved in salivation, they both get a nucleus which is called a salivary nucleus. You've got the superior salivary nucleus and the inferior salivary nucleus. Yeah, the superior salivary nucleus is for cranial nerve 7, and the inferior one is for cranial nerve 9. So this nucleus is going to be responsible for supplying the submandibular sublingual, and this one is responsible for supplying the parotid gland. Okay? And then finally, we had cranial nerve 10. Yeah, the vagus was the only other one with parasympathetic function, and it had a huge parasympathetic function, didn't it? It was the parasympathetic supply of everything in the chest, everything in the abdomen. Yeah, so it does get its own nucleus. It's a big nucleus, and I'm just aware that I've not given myself a huge. I really don't want people to care too much about exactly where these nuclei are. It's more about just knowing that they exist and knowing what they do. But I could have worn this a little bit more sort of over this way, because actually this final parasympathetic nucleus sort of fits in this space here. Yeah, and this is the dorsal nucleus of the vagus. Yeah, obviously for cranial nerve 10. Okay, and all of the parasympathetic functions of the vagus will come from this nuclei. Yeah, the cell bodies are in this nuclei. Okay, so there are some general rules here that can be followed. Yeah, on your afferent side, if you go back to the 2 columns that are the afferent columns of our table, that first column is literally 1 nucleus. And then the other afferent column, the sort of autonomic afferent column, just divide it between visceral afferents and somatic afferents, and then you've got the remaining 2. On your efferent side, by and large, every cranial nerve that has efferent functions will get its own nucleus for that function. Yeah, Occulomotor Nerve gets its own motor nucleus and its own parasympathetic nucleus. Trochlear gets its own motor nucleus. The facial nerve gets its own motor nucleus for its muscles of facial expression, and then its own salivary nucleus for all of its parasympathetic functions, yeah? And just remember, there are a couple of exceptions. The main exception is this nucleus ambiguus, yeah? It's ambiguous because all of the skeletal muscles that are supplied by 9, 10, and 11 just clump together in this one nucleus, yeah? And then in terms of where they are, like, you know, you compare this to a diagram in a textbook, I'm probably not perfect, probably nowhere near perfect, but as a general rule, put the nucleus where the nerve comes off the brainstem. And other than a very sort of small number of exceptions, you're by and large going to be okay. All right? So, putting this all together then, I'm hoping that I've tried to demonstrate the function, the modality, and the nuclei of all of the cranial nerves. They're all actually intricately linked, and you can figure a lot of stuff out just by knowing the functions of these nerves, and then just applying a couple of like funny little rules to help you remember like how the nuclei are arranged and stuff like that. Yeah. This is really, really difficult stuff. Like, it's one of those where I have to go back and relearn it every time that I want to talk about it, because yeah, this is tricky. But yeah, hopefully that's made sense. Alright guys, that's the end of that one. Thank you very much for watching. I hope that was useful. If you enjoyed the video, please give it a like. If you enjoy me, please subscribe to the channel. And yeah, if you've got any comments, good or bad, or any requests for videos that you'd like me to do, please pop it in the comments. I'll keep an eye out for it. Yeah, thanks very much for watching guys, and hopefully I'll see you in the next one. Have a good day. I'll see you later.